Hello everyone, how are you doing today? I trust you are good. I am Angela Otabo, taking you basic technology. Well, I'm very sure your stay at home has been productive all along. In our last class, we were able to identify wood, we were able to vividly describe the structure of wood, and we're also able to classify wood into softwood and hardwood. And I can remember very well that I gave you an assignment to work on, and I'm sure you have done that. I told you to look around for scraps of wood and try your hands on things like ruler, chopping board, and a piggy bank. And I'm sure you are enjoying the use of what you have done. Well, today we want to look at a very interesting topic, and it's titled Processing Wood. Can we say that together? Processing of wood. Processing simply means the various stages that a material will go through from its raw form all through until it gets to the final finished product. In our previous class, I remember that I told you that when you look at wood in the raw form, it doesn't look attractive, it doesn't look good. But by the time that same wood goes through a whole lot of processes, it comes out looking really pretty and awesome. And that's why today we want to look at those processes that wood must go through before it can come out looking awesome and pretty. Now, there are stages that wood must go through. We call them the stages of processing wood. The first stage is felling of trees. The second stage is transportation. The next stage is conversion, followed by seasoning, and finally preservation. In order to help you understand this so well, we are going to be looking at it under these subheadings. What I mean is that at the end of this lesson, you should be able to define felling of tree. You should be able to explain the conversion of wood. You should be able to explain wood seasoning. You should be able to do simple calculations on moisture content of wood. And finally, you should be able to explain wood preservation. Now, we move on to the first one, which is the felling of trees. Felling simply means cutting down matured trees. Felling means what? Cutting down matured trees. And what do we use to cut down? A power chainsaw, as you can see in the picture you have on the screen. Now, take note that if the tree that is to be felled is from a forest reserved area, it's very important that the feller, the person who is to cut down the tree, the feller must be registered with the government so that he or she can obtain a permit and, of course, approval. Examples of this kind of forest I'm talking about are Akure forest in Nigeria, and also we have the Amazonian forest in Brazil. Now we move on to the second stage. The first stage was what? Felling of a tree. That's good. I'm so glad that you are following. The second stage is transportation of wood. Now this simply means the movement of the wood from the felling area on to the conversion point. The conversion point is also called the sawmill. Now, the logs are rolled out onto a truck using a crane or using manpower, men, as you can see in the picture right on your screen. Now, the next stage is conversion of timber. Now, conversion simply means the process by which logs of wood are sawn into small marketable sizes. I come again. Conversion simply means cutting this log and timber into marketable what? Sizes. So now we will be looking at the methods of cutting timber, the method of conversion of timber. The first one is plain sawing, also known as true and true. The second one is quarter sawing, and then the last one we'll be looking at is tangential sawing. I come again. The first one is what? Plain sawing, also known as true and true. The second one is quarter sawing, and the last one is what? Tangential sawing. Very good. Now, we look at the first one, plain sawing. As I said earlier on, plain sawing is also called true and true. Now, how does it go? The log is cut along the grains into board or slabs of wood. This kind of method is time-saving and cheap. This kind of method is time-saving and cheap. You can see the animation right now on the screen telling you how a plain sawing method is done. Now we move on to the next one, which is quarter sawing. With this method, the log must first be cut into 4. Remember, quarter sawing. It must first be cut into 4, and then each of these quarter will now be sliced either in a radial way, like you can see on the screen, either radially towards the radius or plainly along the radius. Now take a look at the animation that tells you or describes how quarter sawing is done. Now we move on to the last method of conversion, which is tangential sawing. Now, in this method, the planks are cut in such a way that their wide surfaces are tangential. When I say tangential, I mean 90 degrees to the growth rings. Growth rings. Does that word ring a bell? Yes, we talked about it in our last class. Now I go again. For tangential method, the planks are cut in such a way that their wide surfaces are tangential, I mean 90 degrees to the growth rings of the timber. As you can see on your screen right now, you can see the growth rings and the lines being traced tangential to the growth rings. From there, the cutting is done all round. We move on to the next stage, which is wood seasoning. Wood seasoning. Now, wood seasoning simply means the method by which we remove excess water in the wood. Wood seasoning is the method by which we remove excess water from the wood. We have 2 types of seasoning. The first one is natural seasoning, and the second one is artificial seasoning. Natural seasoning is also called hair seasoning, while the artificial seasoning is also called kiln seasoning. Now, let's go to natural seasoning or hair seasoning. In this method, we expose the trunks to natural hair. Now, if you look at the picture on your screen right now, you see this is a very good example of natural seasoning or hair seasoning. In the picture, you see a shade. When I say a shade, a temporary structure where you have a roof and about 4 pillars holding the roof. And under the shade, you have stacks of logs. Stack of logs. Now, you will see that under the shade, the logs are separated. You see spaces in between each of these lines and stacks. These logs are separated with little pieces of wood. These little pieces of wood are called stickers. Now, the spaces in between them allows for air flow. The roof is slopy. The reason being that whenever there is rainfall, it will be able to, slope down along the roof, and then it prevents the rainfall from getting to the wood and also prevents too much of heat from the sunshine from reaching the wood. We also have battens. These battens are like supports to the stacks of wood, as well as the block piers. Now, advantages of natural or hair seasoning are, number 1, it is very cheap to maintain. Number 2, it is very easy to set up. But it has its own disadvantages. And what are they? Number 1, the drying rate is pretty slow. And number 2, we cannot control the humidity or the temperature and even the speed of the hair. Why? Because it's nature. You cannot control nature, and I cannot control nature. Now, we go to the next method of seasoning, which is artificial seasoning or kiln seasoning. This method simply entails the drying of wood in a heating chamber. This method entails the drying of wood in a heating chamber. This chamber is what we call kiln. Take a look at the picture of a kiln. You can see men working on already converted timber, stacking them up together and arranging them on a pile so as to direct them into the kiln. Well, the kiln has its own advantages and disadvantages as well. This method has its own advantages and disadvantages as well. And what are they? The first one, it provides faster drying process. And there is control over the humidity, there's control over the temperature, and as well as the speed of the hair. Why? Because it's just like the oven that we have in our kitchen. We can control the heat, we can control the rates and duration of cooking and baking, and so on. The same thing applies to the kiln. All these factors can be controlled. Well, the disadvantages of this method are the purchase and maintenance is very expensive, and it is very difficult to operate and set up. Now we move on to the importance of seasoning. Number 1, it reduces the weight of the wood. Of course, By the time you have gone through seasoning, the logs have gone through seasoning, the water content is reduced, thereby reducing the weight. Number 2, it prevents insects and fungi attack. Number 3, it prevents deformation of wood, the wood taking an abnormal shape. It prevents deformation of wood. Number 4, it makes painting, polishing, and so on much easier to apply. And finally, the last but not the least, it makes wood super strong and much more durable. Now, we want to quickly go into some calculations today. We have simple calculations on the moisture content in wood. If you have wood just cut down from a tree, how can you determine how much water, how much moisture is inside the wood? Very easy. Just follow me. Now, what is moisture content? It simply means the amount of water content in the wood after felling. Now, we're going to look at the formula for this calculation. This is our formula for moisture content. Now, the units for this calculation, or will I say, the unit for the moisture content is in percentage. Now, let's take a look at this example. And the question says, if a wood sample weighs 60 grams before and 40 grams after drying, find the percentage moisture content. Now, in order to help us understand this calculation, we are going to take it step by step. We are going to take it what? Step by step. Now, the first step we are going to follow now is to state our parameters. State our parameters. What have we been given? The first thing we look at is the dry weight. Okay, let's take the wet weight first. Our wet weight, which is what? 60 grams. Then the dry weight, which is what? 40 grams. Now, moisture content. Which I would like to represent with MC, is what? Unknown. So we put a question mark there. Now, we are making progress. The next step is to state your formula. And what is our formula? Wet weight minus dry weight over dry weight multiplied by 100. The next step is to fix in your parameters. Let's go. Wet weight is what? 60 grams. Good. Then we have our dry weight as what? 40 grams. All over our dry weight, which is 40 grams, all over the dry weight, which is 40, multiplied by 100. Now, 60 minus 40 will give us 20, all over 40, multiplied by 100. Now, 20 multiplied by 100 will give us what? Did I hear you say 2,000? Thumbs up. Now we have 2,000 all over 40, and that will finally give us what? 50. Yes, we got it. We did it. Our moisture content is 50, but we don't stop there. We have to apply the units. Can you remind me our units? Yes, percentage. So our final answer is what? 50%. I have another example I want us to try together. And the question says, a wood sample weighs 100 grams before drying and 80 grams after drying. Find the percentage moisture content. Now we go through the same process. The first stage of our calculation, the first step, is what? State your parameters. And what are the parameters? We have the wet weight equals to 100 grams, the dry weight equals to 80 grams, and then the moisture content unknown. We have a question mark in front of it. The next step is to what? State your formula. And what is our formula? Wet weight minus dry weight all over dry weight, all multiplied by 100. Now, let's fix in our parameters. Our moisture content is 100 minus 80 all over 80 multiplied by 100. Then we have 20 multiplied by 100. That will give us 2,000 over 80. And finally, we have our answer as 25%. That was very good of you. Now, I want you to try your hands on more examples of this calculation. So we move on to the last stage of wood processing, which is wood preservation. Now, wood preservation is the process of poisoning wood against insects and fungi attacks. Now, the materials we use to poison wood is what we call preservatives. The material we use to poison wood is what we call preservatives. How do I know a good preservative? A good preservative. It must be, number one, toxic, I mean poisonous to insects, fungi, and worms. Number two, it must be easy to apply. Applications like brushing, spraying, and so on. It also must be repellent to insects, fungi, and worm. It must be affordable. It must be what? Affordable. So far, we have been able to look at the stages involved in processing wood. We have been able to explain the felling of wood. We have been able to explain the conversion of wood. We have also seen the methods of seasoning wood, as well as being able to calculate moisture content in wood. And finally, we have also been able to explain preservation as far as wood processing is concerned. I would like you to try your hands on these assignments. Number one, list 3 types of wood preservatives. And number 2, list 3 methods of applying these preservatives. Always remember this. God tries his children like silver and gold. He allows them to go through some stages in life, and at the end of the day, they come out looking awesome. Just like wood is tried, going through processes, and come out looking awesome.
Good day, students. I hope you are keeping safe and you are ready for today's class. My name is Yewande Damei and I'll be teaching mathematics. I gave you an assignment in the last edition and I would like us to quickly go through the solution to that assignment. The first question I gave you was a right-angled triangle with sides 8 centimeters, 15 centimeters, and y. You were asked to find the side marked y. Since this is a right-angled triangle, you could make use of the Pythagorean theorem to solve this question. And I believe you remember the summary of the Pythagorean theorem. C squared is equal to a squared plus b squared, where c is always the hypotenuse. And the hypotenuse, I told you in the last class, is the longest side. So, using the Pythagorean theorem, you should be able to find y. As you can see on your screen, the y is the longest side, the side opposite the right angle. And if you substitute the value of a and b into the equation, you will get the value of y to be 17 centimeters. So the marked side y in the first question is 17 centimeters. The second question is a triangle ABC. You were asked to calculate the area of that triangle. And I believe you remember that the area of any given triangle can be calculated using half of the base times the height. Half base times height. But in this question, you are only given the base. The height is unknown. This is where Pythagorean theorem comes to the rescue again. You use the Pythagorean theorem to find the value of h, and then after getting the value of h, you use that value of h to find the area of the triangle. At the end of it, you see that the area of the triangle is 54 meters square. 54 meters square. I believe that is clear enough. So let's move on to our topic for today. Today we'll be looking at another interesting topic, which is factorization. Factorization. At the end of today's lesson, you should be able to find the highest common factor of any number or of given algebraic term. And you should also be able to factorize algebraic term. This will become clearer as we move on. So what is factorization? Factorization simply has to do with writing a given number in terms of other smaller numbers. And if it is an algebraic term, you break that algebraic term into smaller numbers and letters. Factorization, I said again, is breaking down a given number into other numbers. Or if it is an algebraic term, you break it down into other numbers or other letters. Simply put, it is breaking down a number or algebraic terms into their factors. Let's consider some of these examples for better understanding. So, for example, let's look at the number 12. Let's look at the number 30. Let's look at the number 6ab, and then the last one, 14mg squared. For us to, if we are able to break this number down into smaller units or into other numbers, then we can say that we have factorized. What do I mean? 12, for example, 12 can be broken down into You can say 12 is equal to 1 times 12. You can say 12 is equal to 2 times 6. You can say 12 is equal to 3 times 4. But for the purpose of this class, we'll be breaking the number down into prime factors. I believe you remember what prime factors are. They are simply prime numbers. And what are prime numbers? Prime numbers are numbers with only 2 factors, itself and 1. Prime numbers are numbers with only 2 factors, itself and 1. I believe you know why 1 should not be regarded as a prime number, simply because it has just 1 factor itself. So please note and always remember that 1 is not a prime number. So let's list out the prime numbers we have between 1 and 10. The prime numbers we have between 1 and 10, you have 2. Yes, I believe we are saying the numbers. We have 3. What other number do you think has 2 factors, itself and 1? Yes, we have 5. We have 7. Is there any other number between 1 and 10 that is a prime number? No. So these are the prime numbers we have between 1 and 10. Now let's move on to how do we express this in terms of prime factors. For us to do that, you need to break 12 down by dividing it with prime numbers. So 12, we know 2 can go in 12, so let's divide by 2. 2 here we have 6. 2 can also go again. 2 in 6, we have 3. Then 3 in 6 and 3 in 3 gives us 1. So we can say that 12 is the same as 2 times 2 times 3. We have factorized this 12. We've written out the factors of 12. The next one is 30. We need to break 30 down also into its prime factors. So which prime number do you think would divide 30 first? Yeah, I believe you said 2. Good. So we have 2 in 30, we have 15. Which other prime number can we use again? 3 is divisible, so we use 3. 3 in 15, we have 5. 5 is also a prime number. We have 5 in 5, we have 1. So we can break 30 down into 2 times 3 times 5. So the next number is 6AB. This is an example of an algebraic term because it is made up of numbers and letters. It is called an algebraic term because it is made up of numbers and letters. So how do we break this down? It's also simple. We break the number down first. The number here is 6, so we break 6 down. When we divide 6, what are the prime factors of 6? They're simply 2 and 3. So we have 2 times 3. Then these other letters, you break them down individually. So we have times A times B. So we've succeeded in breaking down 6AB into 2 times 3 times A times B. Good. All right, the last one that we have here is 14 mg squared. We use the same approach. You break down the number first. And 14 can be broken down into 2 times 7. You can see that 2 is a prime number and 7 is also a prime number. So we have 2 times 7. Then we have the letter part, which is, the letters here are m and we have g squared. So m is just 1. So we have times m, then times, we have g squared. G squared simply means g times g. It means the g was repeated twice. So g times g, we put that down also. G times g. So you've been able to write out the factors of this number. And take note, I said for the sake of this class, we'll be making use of the prime factors. This said, you need to be able to find the highest common factor of any given set of numbers or algebraic terms. You should be able to find the highest common factor of any given set of numbers or algebraic terms. How do we do this? It's quite simple and straightforward. So we have the highest common factor, which is popularly known as HCF. HCF. How do we find HCF of given set of numbers and given algebraic terms? Simple and straightforward. Let's look at example 1. We are given the numbers 12, find the HCF of 12, 18, and 30. 12, 18, and 30. How do we solve this? It's simple and straightforward. You should understand what highest common factor means. Highest common factor means the biggest or the largest number that can divide through your given set of numbers without leaving remainder. I repeat again, it is the largest factor that will divide through the set of the numbers or algebra you are given without leaving, let me say, fraction now. Are we together? So here we want to look for the HCF of 12, 18, and 30. The first thing to do is you need to break each of these numbers down into their prime factors. So we have 12. If broken down, we have 12 is equal to 2 times 2 times 3. 2 times 2 is 4, and 4 times 3 we know is 12. 18 can also be broken down into 2 times 3 times 3. 2 times 3 is 6. Then 6 times 3 is 18. Then the last one, which is 30. So we have 30. 30 can be broken down into 2 times 3 times 5. So how do we find the highest common factor here? We look for the number that is common to the three of them. If the number is common to 2, you don't pick it, you leave it out. But the number we are talking about must be common to the 3 numbers given. Let me use this marker so that you can see the difference. So which number? If you look closely, you see that 2 is common to 12, common to 18, and common to 30. So let's circle that out. Let's see. 2. There's no other 2 that is common, so we leave that out. The next number here is 3. Let's see if 3 is common to the 3 numbers we are given. 3 is common to 12. We can see this here. 3 is also common to 18, and 3 is common to 30. So here we can so we have another 3 common to them. Is there any other number that is common here? From what we can see, we have 2, 3, and 5. There's no other common number. So we can conclude by saying the HCF of 12, 18, and 30 will simply be 2 times 3 because we have these 2 factors being common. So the biggest factor that would have there will simply be the multiplication of the 2 factors. So we have 2 times 3, which gives 6. I believe this is clear. It's something I believe you should have or you are used to by now. So let's move on to the core. How do we find the HCF of algebraic terms? It's simple and very similar to this. So let's move on to example 2. Example 2. Find the HCF of 4CD squared and 10A squared D. don't be afraid. These are just combinations of numbers and letters. The first thing we need to do is we simply break each of the algebraic terms down. We break them into bits, then we bring those things, those numbers or letters that are common, we bring them together. So let's break this down. 4cd squared. 4cd squared can be broken down into, like I said earlier, you need to break down the number first. 4 we know can be broken into the prime factors 2 times 2. So we have 2 times 2. Then we have c times d squared. D squared is simply d times d. So we break this down also to d times d. I believe you are following. The next thing to do is you pick the other term and break this down also. 10a squared d. 10. You break down 10 first. 10 can be broken down to 2 times 5. So we have 2 times 5. Then we have a squared. So what do you think a squared will be? Good. I believe you said a times a. So we break that down also. Times a times a. Then the final letter we have here is what? D. So we have times D. To find the highest common factor, you find the factors that are common first, then you multiply them together to get the biggest factor possible. So let's look closely and look for the factors that are common between these two algebraic terms. We can see here that 2 is here and 2 is also here. 2 is a factor of this algebra and 2 is also a factor of this. So let's circle that. And for this, 2 is no longer common. Let's move to the letter section and see if we have any letter that is common to the two algebraic terms. We have C here, but there's no C here, so we leave that out. We have A here, but there's no A here, we leave that out. Okay, we have D. So let's see, we have D here and we have D here. So we can see that the D is common. So far, we can see that we only have 2 factors here that are common. So to obtain the HCF, you simply multiply the 2 factors together. And that tells us that the HCF of the 2 numbers will simply be 2 times D. And 2 times D gives us 2D. This said, you can see, I told you earlier on that it's simple. Mathematics is very simple and easy if you would pay attention and you keep practicing. Let's move on quickly to factorization of algebraic expressions. Expressions, now, we are not talking of one term, we are talking of combination of 2 or more terms. You could be given 2 or more terms and you are asked to factorize them. How do you do that? Very simple. It's just like what we've been doing all along. So, how do we factorize algebraic expressions? Simple and straightforward. Factorization of algebraic expressions. So let's consider example 3. In example 3, we are given this particular algebraic expression to factorize. You are asked to factorize the binomial. Let me write it together. The binomial expression. And the binomial expression is 9ny plus 3nz. how do we solve this problem? Now, I want you to take note of the word binomial. We know that the word bi means two. So this expression is called a binomial expression because it has just two terms. It has just two terms. If it is an expression with just one term, we call it monomial. If it is two, we call it binomial. If it has three terms, then we call it trinomial. And if it's above three, you simply call it polynomial. You can see that math is step by step. We have different steps or different names for different items. Good. So let's solve this problem. This is a binomial expression and we want to factorize it. How do we solve it? Simple and straightforward. The first thing is you need to split out these numbers, break them down into factors, identify the highest common factor, then you bring out the highest common factor. So this is what we are to do. 9ny is equal to, let's break this down. Break down the number part first. 9 is what? Yes, I believe you said 3 times 3. Good. So we have 3 times 3. Then we have n times n, and then y times y. The next term is 3nz. So 3 is already a prime number, so we write it out. 3 times n times z. So we need to look for the common factors. Let's check and circle out the common factors. Here we can see that 3 is common to the two terms. If you look closely also, you see that something else is common, which is the n. You have n as a factor in this term, and you also have n as another factor. So let's group the n together. Is there any other factor that is common? 3, there's no 3 here. Y, there's no y here, and z, there's no z there. So we can conclude and say that our HCF is equal to 3 times n, which gives us 3n. Now, we're not just asked to find the HCF, we're asked to factorize this expression. This means that how else can you write this expression? How else can you express this as product of its factors? So here we have 9ny plus 3nz is equal to, now we know that 3n is common to both 9ny, it's also common to 3nz. So we bring the highest common factor out, which is what? 3n. Whatever you have left in the algebraic term, you write them or you put them in brackets. So we have, since 3n is common to the two terms, we bring it out. Then what do we have left in this term? We have 3 and y left, which gives us 3y. So you simply put that down, 3y. Then the sign that connects them is the addition sign, plus, what do we have left here? We have just z. We know 3 is a factor and n is also a factor, which we have brought out. Then what we are left with here is z. So we put that down and close our brackets. So this is simply telling us that you can, another way by which you can write 9ny plus 3nz is 3n into bracket 3y plus z. If you expand these brackets, I said the word expand. So this means that the opposite of factorization is expansion. So if you expand this bracket, you will definitely get this back. Let's check. For this first term, we have 3 times 3 gives 9. N times y gives ny. So the first term we have here will simply be what? 9ny. Let's check the second one. Then we have plus 3 times 3n times z. That will give us 3nz, which is what we have here. So factorization is simply showing how else you can express whatever term or whatever expression or numbers you are given. Let's look at example 4. Let's consider example 4. Factorize the expression 12ad squared minus 30a squared d. Simple and straightforward too. The first thing is you pick each of the algebraic terms, you break them down, after which you look for the highest common factor. When you've gotten the highest common factor, you bring it out, then you write the remainder in the bracket with the sign in between them. So let's solve. We have 12ad squared. 12ad squared, you break down the 12 first. 12 is 2 times 2 times 3. So we have 2 times 2 times 3. Then we'll break down ad squared. Ad squared is simply a times, then d squared means d times d. So we'll break d squared into d times d. The next one is 30a squared d. Let's break that down also. 30 is 2 times 3 times 5. So we write 2 times 3 times 5 times a squared. A squared means a times a. A times a times, then we have d. So let's identify the factors that are common to the two terms. We can see here that 2 is common. Yes. 3 is common. Is there any other thing that is common? Good. I can see that A is common. And also, I think we have D here. In D is common. So let's write out the common factors. We're writing out the product of the common factors. So the HCF is simply the product of the common factors. So we have 2. 2 is common to the two of them. Times 3. 3 is common. Times A. Times D is common. So finally, our HCF is equal to 2 times 3, which we know is 6AD. So we've been able to identify the highest common factor of this algebraic expression to be 6AD. The next thing is, how else can we write out this expression? So we have 12AD squared minus 30A squared D is equal to, since we know that 6AD is common to the two terms, we bring that out, we factor it out. Then whatever we have remaining in each of the expressions, we write them out in the brackets. So what do we have left here? We have 2 times D. I believe you can see that. 2 times D. So we have 2D. Then in this expression, we have minus connecting them. So you write your minus. Then in 30AD, what is left? 30AD, we factored out something. So we have 5 and A left. So we have 5A left. Let's check and see if we are correct. So we have 6AD times 2D. 2 times 6 gives 12. We are on track. Then we have times A, we have 12A. D times D gives D squared. So we see that we came back to 12AD squared. Now let's check the second part of the expression. Let's see if we are correct. 6 times 5 is 30. We have our 30. Then we have A times A is A squared. Then we have D out here. So it means that we have done the right thing. So in other words, we've been able to express this, we've been able to write out this expression as this. So you can use any of this. You can see that mathematics teaches us different ways of doing things. And if you put this into practice in life, you'll be able to achieve a lot of things. I'm going to give you an assignment that would review the next time we meet, and I believe you can see it on your screen. Find the HCF of 5a squared plus 20ab. The second one is you have to factorize the expression 12cm squared minus 16d squared m. I believe it will be pretty simple since we have explained in the class. Factorization is a very important topic in mathematics, and I would love you to pay attention to it. Your daily life can become easier if you factor things out and see how you can bring them together again. God bless you. Stay safe and keep solving mathematics, because mathematics is fun.